Real quick before I get into the video, I want to let you guys know that I've got a huge giveaway going on my website, and it is for 500,000 YouTube subscribers on my main channel, 100,000 Instagram followers. Big prizes, lots of prizes. Rockler really stepped up with a tremendous amount of prizes. We also got a saw stop table saw, a Laguna lathe, so much more. I'll have a link down in the description below. If you haven't already signed up, check out the link. And yeah, now we'll get into the video. Hey folks, how you guys doing? Hope you're all having a great day today. This is my CNC machine. It is an Axiom AR8 Pro Plus. And anybody who gets a CNC machine, there's two things that I recommend you doing right off the bat. One of them is very important, and the other one is a creature comfort, something that's very beneficial for you, the user, but not 100% necessary. The first thing that is very important is to use the CNC machine itself to flatten the spoil board so that it is in perfect plane with the Z-axis of the machine. I've already done that. The second thing that I really recommend is to, again, use the machine itself to scratch a grid into the spoil board to let you know 100% the maximums and minimums for your X and Y values for the capacity of your machine. As you can see, I already have the grid cut into this wasteboard, so I'm not going to show it being cut. It's a very basic cut anyway, kind of boring. Instead, I'll show you how I got to this point on the computer. But first, a couple things that make this grid very beneficial, in my opinion. And then also, obviously, this is cut into the wasteboard, and the nature of a wasteboard is to be waste. So sometimes, depending on how precise you like to get to the surface of the wasteboard, you're going to end up cutting this out and destroying it. So if you're chopping away your wasteboard more frequently, well, then you'll have to flatten it, lose the grid, and cut the grid again. I haven't run into that situation because I like to just barely skim the surface. You can kind of see, maybe it's off camera, but you can kind of see some of the last cuts up here. Just barely skimming the surface. But the benefits of this grid, number one, like I said, the machine cuts the grid. So therefore you are using the exact limits of the machine to cut the grid. So you know that nothing can be cut on that side of this line and nothing can be cut on this side of this line. It gives you better placement of your material onto the wasteboard for various different situations. And that means you can also go somewhere inside the field of this wasteboard, away from the home position, and get, again, precise positioning with the X and Y directions. And that's beneficial because this particular machine, yes, every machine has a home, which is your 0, 0, and your X value, in this case, the front left corner of the machine. But this machine has up to 9 programmable origins. So you can see number 2 and number 4. These intersections here are my number 2 and number 4 origins. So for various different situations, I can switch to that origin and now accurately clamp my material in place based upon these grid lines. For example, this one over here is very beneficial because for smaller stuff where I don't need the maximum capacity of the machine, this gives me the best clamping options. It's immediately on this outside line or outside edge of this track, so I can put clamps in this track and still reach the edge of the piece. And it gives me some more surface area up in front here to clamp onto rather than going off of this home position and not having as much material on the front side of the machine or the side of the machine over here to clamp to. And of course, I have one leg of the clamp on the machine bed rather than on the wasteboard surface. So that's a couple reasons why I really like this. And I've also taken the time to just write out the numbers here in the increments of the grid, which is a 2-inch by 2-inch grid, which also again allows me to just glance at the wasteboard here and get a better representation of distances or positioning. So I really like it. I really recommend everyone cutting one of these in. Yes, you can get some spoil boards for some CNC machines that already have the grid in place, but a printed grid on a spoil board is not as precise as the machine actually cutting it. Before going to the machine to generate a cutting file, I need to determine the maximum values for X and Y on this particular machine. Now, it may be different for every machine, but in this case, this machine is run off of this controller. So what I can do first is right here, it's not at its home position. So I need to change the machine or move the machine to its home position, press home, press OK. And you can see it's going to go all the way up in the Z direction until it hits a limit switch, all the way over into the X direction until it hits a limit switch, and Y. So now the machine is at 0, 0 in X and Y value as far as the physical limits of the machine. Now, my controller says that I'm not at 0, 0 X and Y. Instead, it has different values here. Now, as I said, this machine, you can have multiple origins. That's what this 5 comes into play. I'm at origin number 5. Holding down menu and pressing a different button goes to a different programmable origin that you can change very easily. In this case, I'm going to use 5 because that's one I don't use. Let's go to 5. Those numbers are wrong for where this machine is at. Instead, I want to hit X, Y, 0, and that'll change my values to say that this origin 5, has an X and Y value at 0 at that position over there, which is 0, 0 on the machine. It's the machine's home. It is this particular origin's location now. So to determine the maximum X and Y value, I can hold down X and Y plus, and this controller, this machine rather, has it programmed for the maximum X and Y values, so it's not going to damage anything by going too far. It's going to know based upon the home position where to stop. So if I hold down X and Y positive, the machine moves in the X and Y positive directions, and I can let go of X once it stops at X. I stopped at X, I'll let go of X. Now we're just moving in Y until it reaches the maximum capacity of the machine, which in this case, the controller will tell us that the maximum X value is 610 millimeters. The maximum Y value is 1,210 millimeters based upon the machine's origin, the machine's home, and then moving furthest away from it. So now we can take these values and plug them into the computer. Our maximum X and Y values are 610 millimeters by 1,210 millimeters. And as you can see, that's not exactly 24 inches by 48 inches. However, this machine is, it's produced and sold here in the United States where people are familiar with imperial units. So it's much easier, it's much more appropriate to put an approximate number, 24 by 48 inches. However, the machine is set to metric units, so 610 millimeters by 1,210 millimeters is what we need to establish the job size. Then I can switch back over to inches because that's just what I'm more familiar with. So here in VCarve, you can see that I have a job created that has an X value of 610 millimeters and a Y value of 1,210 millimeters. My thickness or the Z value is 10. Doesn't really matter, but that's just a nice whole number. And once the job is created in millimeters, also I'm going off the machine service. Once the job is created off of millimeters, I'll press OK just to solidify the area that I'm working with, go back to my job dimensions, and then switch over to inches, and I get those goofy decimals that really don't matter. Press OK. So now I'm working in units I'm more familiar with. There's several different ways to create this grid, and the objective here is to create the grid with as few open vectors as possible. The reason being is when the machines cut an open vector, they plunge down at the start of it and go all the way to the end of the vector and pick back up. So if you have a bunch of open vectors, the machine is going to have a lot of wasted time where it cuts, picks up, goes to the next one, cuts, picks up, goes to the next one. It's just wasted time in between. And the slower your machine's rapid movement rate, the longer it's going to cut when you have a lot of open vectors. And I'll show you a simulation here or a summary to verify that. So, like I said, multiple different ways to get a grid here, but just for sake, I'm going to, just for the sake of things, I'm just going to draw a line from the snapping to this point over here, snapping to that point up there, press escape, and let's go to array. And in this case, I want to have how many rows? Just one row. I'm going to copy this or array this to the right, which is a bunch of columns basically. How far of an offset do I want? I want a 2-inch by 2-inch grid. So in my X value, I'm going to change that to 2, press tab, change Y to 0, and change my columns to, well, what is an approximate value of 24 divided by 2? Well, that's 12. Press copy, and as you can see, my vertical line copied 12 to the right, and it is not exactly all the way to the machine limits, which is the job size here. So let's press close, add one more vertical line from there to there. Let's press escape and then spacebar to reactivate the last command, which is line. So all of my vertical lines are established. I need horizontal lines. So I'll snap to the lower left, snap to the lower right, press escape. It is still selected. Go back to my array and reverse this. I need to have one column and a bunch of rows. Same offset, not in X, but in this case, Y. So let's press 0 for X, 2 for Y. Change my columns back to 1 and change my rows to, approximately 48 inches divided by an offset of 2 is approximately 24. Let's press copy, and you can see it multiplied all the way up there, but not this exact top one. So let's press close, go back to the line, click here, and click there. So what I have here is the grid. That's what I wanted to draw, but I drew it in an inefficient manner. So if I select all these, that's a bunch of open vectors. I'm going to go to this join button to show you that it is 38 open vectors selected. Now I can join these. It's going to do something goofy, I think, and result in one closed and 34 open. We want to have as few open as possible. So I'm going to hit close, and I'm just going to use this as the slow representation. So just drawing lines isn't necessarily the best thing to do. Let's go to Quick Engraving Toolpath, select our bit, and in this case I used a Whiteside SC70, which is a 30-degree pencil point engraving bit. The important thing there is 30 degrees. We want to have as little material removal as possible because all this is just a reference scratch into the machine surface. And the feed rate, plunge rate, all that stuff, that's specific to your machine. Just for, actually, I think that's what I used is these particular values. But just for the sake of having a baseline or an apples to apples comparison, we're just going to leave these the same. So that's the bit I'm using, 0.03 for the depth. That's fine. And I'm going to name this one Slow Cut. Press Calculate. And press Close. You'll see why it's a slow cut when I go to 3D view with this toolpath selected. You'll see all of these red lines. Red lines are rapid movements. That means where the machine picks up, moves in the air while it's not cutting anything to another plunge location. So there's a tremendous amount of movement where the machine is not cutting anything. It's just rapidly moving in the air, and rapidly moving in the air isn't making any progress on our cut. So that's why this is not ideal to have that many open vectors. So I will, let's just go to 2D view. Let's uncheck this toolpath so it's no longer represented on the screen. Select everything, all of these open vectors, and I'm going to delete it. That's okay, I didn't delete the toolpath. I can still select this, and it still shows where that was calculated. Now I'm going to draw it in a little bit more efficient manner. And there's multiple ways to do this. You can simply go to your line tool and snap lower left. We're going to start both of these at lower left. And we're going to go up all the way to the top, click, drag in this direction, which is, it's snapping to the horizon. And once it snaps to the horizon, let's press 2, enter, come down here, snap to this, 2, enter, come up here, and I can continue this back and forth. Click to enter. Click to enter. And this will produce one open vector all the way across. Now, you might say, well, why don't you use the array tool to array all of these and then just connect them? I'll show you, you can do that in just a second. But I'll snap to this end over here. I don't care if it's 2 or not. But regardless, what we're doing is we're getting one open vector for all of these cuts. It just zigzags back and forth. Now, this is going to be kind of in the way visually as I make my horizontal lines. So I'm going to move it out of the way just for visual representation. M for move, and I'm going to move it relative 25 inches in the X direction, press apply. That way when I'm ready to move it back, I just move it back negative 25. Okay, so now I need to repeat this for all of my horizontal lines. So the same thing can be done back and forth, back and forth, back and forth, but there's a lot to travel there. So instead, what I'll do is use the line tool once again. Again, starting at the same spot, click, drag all the way to this corner, go into this direction to enter, go all the way into this direction, snapping at that line, 2 inches, enter. And now I'll press escape. And what this does is it gives me one loop, I guess you can say, one full travel for this array. I can select that, go to array, and this time I want to have, again, one column. But how many rows do I want? Well, it depends on my offset. In this case, I'm going 2 vertical on this side, 2 vertical on this side. That's a positive value of 4 for the Y direction. Press 4. And how many rows do I want? Well, approximately 48 inches divided by 4 is, in fact, 12. Let's press copy. And there we go. Now we have a bunch of, once again, open vectors, but they are connecting and forming a chain. I did not make this horizontal line up here with that array, so let's press close. Let's go to our line from this corner over to this corner. Let me zoom in this corner, press escape. Now you can see that this vector extends too far to the top, but this one stops it. So what I can do is use the interactive trim and trim this one back down to there. Press escape. Let's back up. So now we have a bunch of open vectors, but in this case, because they are basically forming a chain back to back to back to back to back, we can select all of those, press join, and it's going to take those 13 open vectors and vectors after joining, join them back down to one open vector. Let's press join. So now if I have the machine cut this, it's going to plunge down here and continue this one open vector all the way to the end. And then if I stack this one on top of it, it's going to maybe make one rapid movement and cut all of those lines as well. Sometimes, depending on your start and stop locations, depending on any overlap, I haven't quite figured out the specifics, but sometimes you can join 2 chains like this that are 2 open vectors into one open vector. So let's see if we can just M for move. Let's move this back a negative 25 inches, enter. So now they are stacked. And again, I can make this toolpath to cut these 2 open vectors, but sometimes if I select both of these, I can press join. And in this case, it's going to go ahead and close it. I don't want to do that just for the sake of making sure it doesn't just make some inefficient movements. I want to force it to start in this corner, stop in that corner for both my directions. So now let's grab these 2, go to quick engraving toolpath. Everything is the same bit, same depth, same speeds. And I'm going to name this one fast cut. Press calculate. And if I go to my 2D view, you can see that there's no red. It's just going back and forth as it should. Press close. Oh, actually, there's one red right here. So it is going to cut all of my horizontal or vertical, whichever one I selected first. Stop, go all the way back to the beginning, and cut all the other direction. But you can see it's a lot less red than that. So therefore, less rapid movements. I'm going to select both of these and go to Summary of All Toolpaths. And you can see that the slow cut in this case is at those feeds and speeds, 31 minutes. And the fast cut is at 26 minutes. Now, that's because I'm using a rapid rate of 200 inches per minute, which is standard on my machine. If you're using a machine that has a not so fast rapid rate, then this discrepancy is it's way different. So let's change this down to say, let's just say your machine has a rapid rate of 100. So now we're at a 10-minute discrepancy versus what was it? My bad, I hit the wrong button. 10 minutes versus 5 minutes. Let's say your machine has a 50 inches per minute rapid rate. Well, then you have a 20-minute difference. So reducing the amount of rapid movements will really reduce the amount of cutting time with all other scenarios equal, like feeds and speeds and all that. So let's press close, and in this case, all I want is my fast cut, and then I can save my toolpath based upon my particular machine and go ahead and cut it. Cutting the grid it's very easy. It's a very easy process. Determining your maximum X and Y values may be the biggest challenge depending on your particular machine, but it's something that I recommend everybody do regardless of their machine because, like I said, it gives you 100%, no questions about it, the maximum X and Y values that your machine is capable of cutting, and therefore allows you to very easily glance at the wasteboard and get a visual representation of where the machine can and cannot go, which therefore allows you to better place stuff onto the wasteboard easily and accurately. So an example of this is, like I said, my number 2 origin here. I use that all the time. That's pretty much my most common origin. And I can set a stop block right here. In this case, it's a store-bought one, but you can make one. Just screw a piece of wood right down to the wasteboard. But I can put that right on the origin's 0 value for Y and line it up all the way with that scratch line and have a repeatable position, a repeatable stop block, I should say, to position a bunch of things that are going to be cut in a very similar fashion. For example, it's December when I'm recording this video, and I made a bunch of cutting boards for friends and family. So I can set this here and have all of my cutting boards very accurately positioned to cut stuff that is common amongst all the cutting boards, like in this case, the juice groove here on the top. But anyway, there's enough rambling in one video. I'm going to have a bunch more CNC content in the future. So you guys take care, have a great day, and I'll catch you in the next video.